Series of talks, we're going to have a look at classes within C++. We'll start off really introducing them. By way of introduction, I suppose I should set out that I'm assuming that you, as everybody will be, familiar with object-oriented programming. So you'll be familiar with how classes work within Java and say, for example, C#. What we want to do is a bit of a compare and contrast in terms of how classes differ and in what respects they also are the same within C++. So there are some important similarities, also some important differences. Start off with the key difference. Within languages like Java and C#, managed languages in general, classes or instances of objects are generally accessed by a reference. So actually, if we have a look at the instantiation, normally within, say, Java and C#, you see this the bottom example on the right-hand side, where we have some method, we're creating some class is equal to new instance of that class, and we're possibly passing in some arguments to a constructor. That will create, because it's the new keyword, allocate space on the heap for storing that object, and we get to access that object through the sum class reference as a reference variable. Effectively, it's if you like, it's a static pointer. It always points to that object, and that's our way of accessing those objects. So it's always indirect through a reference. You can compare and contrast this then with a way of instantiating it within C++, and you see that on the top. So in the top here, we're declaring some class, and there's no new keyword, just we're declaring it in exactly the same way we would declare an integer of a certain name, and constructing here, passing in some arguments. So in this case, it's actually created as a value type. So in this one, in the example here, it would be created and stored on the stack. And some class is actually the object itself, so we would be accessing it directly, not through a reference or a pointer to it. And that's an important distinction, because it means that in C++, when you are creating objects, you get to choose if you want them to be value types created on the stack, where they're sort of short-lived and you have immediate access to them, or do you want to have them created on the heap, where you have a pointer or indirect reference access to them. Now it says here in C++ the default is a value type, but that's only to say that the example we show at the top is probably the most straightforward way of creating one, but of course you can use the new keyword by way of explicitly saying you want it stored on the heap. That has some important consequences. The most important one is the notion of assignment. So again, let's have a look at how Java and C# and other managed languages use reference types, how they work. And you see that example on the bottom right. So here we're doing some class A is equal to a new instance of that class. And we've got some class B, so we've got a reference type B, and we're saying B is equal to A. What that will end up resulting is what we see underneath, where we only have one object. It's the one that was created through the new keyword. But we have two references. We've declared a reference A and a reference B, and through the assignment both A and B point to the same object. So it's one instance but two references to it. If you then compare this with the C++ example on the top, like just as a reminder that you know in C++ value reference type we get to choose. So here we're doing just so some class A. Now in Java, that only gives you a reference, doesn't create an object. Because it's C++, it's the same as doing, int A. It will create an object of that type, in this case, whatever class it is we have defined. And that gets to be stored in the stack. If we then do in line 2, some class B is equal to A, that will create a separate instance of that class and copy across the values that are stored within the A instance into the B instance. So you end up actually with two different instances that likely share the same set of member or properties within it. So that is quite a fundamental difference. It also, because we can treat instances of objects as our classes objects as value types, it means that we need to have a couple of additional constructors. And these are constructors that we simply don't have inside Java or C#. So for example, a copy constructor or a copy assignment constructor. So both of them are concerned where you are creating a new instance of an object and it has been initialized or populated by an existing instance of that particular class. So it is a copy constructor. We're copying the contents from one instance into a second instance. And the copy assignment, and we'll see that they're actually quite similar, but you sometimes can have small differences between them. In this one, it is occurring through the equals, the assignment operation. But when we have a look at constructors in more detail, we'll get into the nitty-gritty of this. Just by way of providing a few other key differences between maybe what you're used to in terms of Java and C# and C++, we'll have a look at class structure. Within a class structure, so we're quite content with the notion that when we declare methods or properties within a class, we can give them a defined scope. They can be public, available and accessible and visible to everybody. They can be private, only accessible or visible within that particular instance. There may be other ones like protected for sharing things through inheritance hierarchies or package access or other types of ones, but the main defining characteristic is public or private. Within Java and C#, you declare a method or a property. You can add in that keyword to then say precisely for that method or property what type of scope that it has. C++, slightly different. We actually have two regions that you define within your program. Well, in this case, for public and protected, we can add another one for protected if we want. So there we are, public and private. We have a public section, so public semicolon, and then everything that follows after that has a public scope. It's generally accessible. Private colon down at line 11, everything after that then is private. Only really accessible within that or to some other special occasions where you have, for example, a friend function where you permit it to get access to it. As another reminder, for C++, we generate separate our functionality into CPP and .h files. So generally, the .h file contains the header file of our class. CPP contains the implementation then of the class itself. For implementing methods within our CPP file, I generally use the form that's shown here. We have the return type, the name of the class which it belongs, two colons, then sort of separating out for the method name and the argument list for that. Exceptions to that are constructors and destructors for either how you put together, construct a class, or destruct it, how you take it apart whenever it's being released. A little bit, I mean, the variables and functions listed in the class declaration section, we call them class members or data members or instant variables, those types of ones. For functions, we can refer to them as member functions or methods. I generally talk about methods within a class or properties within it, but you know, it's a common enough set of or a common enough lexicon for doing this. Takeaways in this is only one. The main point, I suppose, to take away from it is that in C++, when we create an object, it is an instance of a class. It's very much similar to a value type. We can store it by default, if you like, on the stack or on the heap if we're using the new keyword. And that gives us a number of advantages. If we do want to have a short-lived object that just lives on the stack, we can do that. But it also introduces a number of additional complexities that we need to be careful whenever we are assigning one object to the other. And there's a few additional constructors that come into this that we will have to take into account. And we'll be looking at those shortly.